for this question we want to find the equation of the normal, so we need to understand what a normal is. Well, at the curve, if I draw the tangent to the curve, okay, then the point at which the tangent touches the curve, if I draw a line through it perpendicular to the tangent coming through that point, then that is what we call a normal. So the normal is perpendicular to the tangent. And to find the equation of a normal, it's a straight line, and the equation of a line, we know, takes that format, where the coordinate is x1, y1. That x1, y1 is the coordinate which the normal passes through, and that will pass through, in this particular question, 0.33 minus 5. And so what we need to deal with then, I got my x and y1, I need to find m, which is the gradient of the normal. And then, because the normal is perpendicular to the tangent, then if I can find the gradient of the tangent, then I can then get the normal by using the fact the product of the gradients is minus 1. And then, to get the gradient of a tangent, when I work out the value of dy by dx, the formula for dy by dx, that gives me the gradient of the tangent. So in this question, what I'm going to do, I'm going to work out dy by dx, and then to find the gradient of the tangent at this particular point P, then I know that x equals 3 at this point. I'll sub x equals 3 to get the value of the gradient of the tangent, then use the fact that the normal and tangent are perpendicular to find the gradient of the normal, which then gives me m to use the coordinate x1, y1. So part A then, so gradient, find the gradient of the tangent, and work out dy by dx. So differentiating 2x squared goes to 4x, minus 10x minus 10, and differentiating 7 goes to 0. So that's the formula for the gradient of the tangent. So at point P, 3 minus 5, and I substitute x equals 3 into this formula to get the gradient at P. Gradient of tangent will be 4 lots of 3 minus 5, sorry, minus 10, this formula here, which is 12 minus 10, which is 2. Then, so to get the gradient of the normal, this is perpendicular to the tangent. So if I write the gradient of the tangent is 2 over 1, and to find the perpendicular gradient, I flip that fraction upside down, which is 1 over 2, and I change the sign, so it's positive 2, so it will be negative a half. So the equation of the normal, so it's y minus y1 equals mx minus x1. So P3 minus 5 is my x1, y1. So it'll be y minus minus 5 equals minus a half x minus 3. Changes to y plus 5 equals minus a half x minus 3. So if I double the equation to get rid of the half, so that's 2y plus 10 on the left. Multiplying by half just leaves me with minus 1 x minus 3. 2y plus 10 is minus x. Be careful here, minus 1 times minus 3 is plus 3. So 2y equals minus x. Take the 10 over, it's plus 3 minus 10. So 2y is equal to minus x minus 7. That's okay, or I can take it all onto one side and equate it to 0. So there's the equation of the normal. For part B, the point Q lies on C and the tangent is parallel to the x-axis. Well, if the tangent parallel to the x-axis is going straight across, it's horizontal. And a line that goes across like that horizontally, its gradient is 0. Okay, so that means that with the tangent then, I want the gradient of the tangent to equal 0. So that means dy by dx is equal to 0. I've worked out dy by dx as 4x minus 10. So I'm solving 4x minus 10 equals 0. So 4x equals 10. X is 10 over 4. That cancels down to 5 over 2. I feel like x is 2.5.